Hi there, my name is Jeffrey Pollock. I'm currently a philosophy student at the Pontifical University of the Holy Cross in Rome, Italy. Um, I wanted to share some thoughts that I've recently been kind of working on ChatGPT, kind of that everyone's talking about. I also have a background in engineering. I did a doctorate at the University of New York in kind of cybersecurity privacy. And so I think there's a lot of issues that come up with artificial intelligence in general and ChatGPT in particular that kind of require this perspective of both engineering and philosophy or sort of ethics to think about what it means to have a technology that in some ways imitates the way that our minds work, and so brings up a lot of sort of human issues as well as technological issues. So, but in order to understand those, you have to know actually how the technology works. So I thought I'd record a little bit of a presentation on what I've been thinking about in the last few weeks. So the first thing I think to know is that the way that neural networks function is different than the way that kind of traditional systems make decisions. So let me just kind of take an example here. Imagine I have to make a decision about when I'm going to take the train. So I live about a half an hour outside of Rome, Italy, and on certain days I take the train into Rome, and on certain days I stay here. So you can imagine that I want to make the decision about whether to take the train, or if you want, you could imagine that maybe the company that runs the train is trying to figure out when I'm going to take the train and when other people are going to take the train. So on the bottom here, I've got sort of my decision equation, right? Which is that basically I tend to take the train in two situations. One is that I'm going to work, so like during a weekday, and the other is that I want to go, let's say, to the park to kind of rest on the weekend. And then I think the part that you can't see because it's covered by my video says that, and I should not be sick. So if I'm sick, I'm not going to take the train in any case. So I can draw this sort of decision where the traditional sort of and or circuit-based decision framework. So first of all, when am I going to go to work? I'm going to go to work, let's say, on Monday through Friday when it's not a holiday. So if it's, let's say, like New Year's, then it's a holiday. So even if that falls on a Tuesday, I'm not going to go to work. So basically, I have this first and gate, which is I'm going to go to work if it's Monday through Friday and not a holiday. On the other hand, I'm going to go to the park if it's not Monday through Friday, like a Saturday or Sunday, and let's say if the weather's good. And so in either or of these conditions, I'm going to, let's say, go to take the train. But I also want to make sure that I'm not sick. So I also require the condition and not sick. So then I have these sort of inputs on the left-hand side and output on the right-hand side for all the conditions in which I'm going to take the train. Now, this could be further generalized. So here I've shown a decision framework with, let's say, I don't remember if it was 2 or 3 AND gates or 2 or 3 OR gates, but you could imagine basically wiring up any sort of number of combinations of different AND OR gates. So this thing could get sort of more complicated. I think I've sort of jumped a slide, but basically what I wanted to say is that if you want to take these decision frameworks and make them more and more broad, you can start adding more and or gates. And you can imagine that, maybe if you're if you're kind of thinking about these binary inputs, you've already said, aha, but actually there's only 16 combinations that you can think of. So that's true, but you could imagine a more general decision where you have inputs that are not binary. And so actually you could have sort of any number, infinite number of combinations of those inputs, and basically your decision, let's say, could be based on the product of two inputs, or it could be based on, like a sinusoidal function of two inputs or 3 inputs. So basically you could have a lot of combinations. And this is sort of what neural networks try to capture. So instead of having just and or gates, you have similar nodes, let's call them, which combine inputs based on this kind of sigmoid function. It doesn't really matter what that function is for the purpose of this presentation. It's non-linear, so it kind of adds more complexity to the decision. But the basic idea is that each of these sort of blocks, each of these sort of nodes, receives input from several different sort of input factors: holiday, Monday through Friday, sunny day, sick. And the neural network is trained by adjusting the strength of these inputs, right? We can also say that these are the weights. So in the equation, this is like WI, the set of WI, where I is, let's say, 1 to 4 for 1 being holiday, 2 being Monday through Friday, et cetera, et cetera. And so basically, when you change these weights, you change the strength of the connections between nodes. And the additional sort of complexity of neural networks comes from the fact that we're not just talking about one layer of inputs, but those kind of combinations can also be combined again in additional layers. So here we have 3 layers of a neural network, but you could have a lot of layers. Now, I'm not going to go into in this video how neural networks are trained. Of course, this is sort of the whole interesting part of how neural networks work, is how with time and with the input of different data, these neural networks learn to adjust the different connection weights. I'm not going to talk about this sort of different algorithms, backpropagation, things like that. I'm just going to skip that. But the basic idea is that these neural networks receive a whole bunch of input data, and based on that data, they form these connections. I like to say, even though I think it's probably an oversimplification, that this neural network is sort of forming a map between different concepts. So the way that these connections are formed or eliminated sort of creates like a mental map of different points in the data set that it's trained on. One thing to note is that here's sort of a general view of how we typically represent a neural network. One thing to note is that in the traditional decision network that we saw, so whether I'm going to go take the train or not based on and or gates, we saw that these middle layers had a certain human interpretable value. So I think in that case it was whether I'm going to go to work or whether I'm going to go to the park. So in the end, if you see a decision made by this traditional network, you could kind of explain how it made that decision. You could say, oh, he took the train, and that's because in the middle layer, it was he went to work, let's say. In a neural network, there's often sort of so many hidden layers and so many different nodes, and these things are adjusted by algorithms that you don't know the meaning of these hidden layers. So this leads to kind of we'll see the ethical issue later, that a lot of times the decisions made by neural networks are not explainable or easily explainable. And actually there's people working on trying to kind of modify this. It's called explainable artificial intelligence. But anyway, that's one sort of challenge. So these networks are basically really good, and we've seen that kind of in the past years, they've been really successful at doing things like image recognition. So there's this article on Medium where if you want to build your own neural network, you can build a neural network by yourself. Got to download Python, I think, things like that, which is capable of distinguishing cat images from dog images. So you can kind of give it a try. It's fun to build these things. But this is something that people have been doing for I don't know if the last 10 years but more or less for some number of years we've been able to sort of do image recognition by neural networks in a very impressive way. Now, moving specifically to ChatGPT, how does this work? Because this is something that I'm assuming in this talk that you've already played around with ChatGPT. So maybe you've already done some sort of experiment like I did here, which is to ask it, please write a 20-line poem about Aristotle. And you've been sort of surprised to see that in ancient Greece, a man did roam, whose name was known to many a tome, et cetera, et cetera. Or that maybe you've asked ChatGPT to write computer code. I've been super impressed by its responses. So I haven't sort of shown all these impressive examples, but you've probably done that yourself. So anyway, how does ChatGPT work? Well, a few different points. In this slide, my point that I want to sort of make is that basically ChatGPT has 2 different neural networks, or 2 different kind of, let's say, subsets of neural networks. One is to understand the text prompt that you've given to ChatGPT, and the other is to take its sort of reasoning and output that in a text that you understand. And so that's the sort of basic idea. Both of these networks are trained together, and then they're used every time that you make a query to ChatGPT. Specifically, what we're talking about here is neural networks that are large language models. So I'm not really an expert on this, but the basic idea is that you train a neural network by putting the text prompt into your neural network as inputs. And so I think that the different units of text that you include as inputs are called tokens. And you can see in this example that a token could be like just one word, for instance. So that kind of serves as an input to train the neural network. Or you could also have tokens that are more than one word. So maybe you have like 2 or 3 words together. So please write A is sort of one token that is treated all together. And so large language models are typically used to do things like, let's say, predict the next word in a sequence of text, or to kind of fill in a missing word or something like that. Obviously, ChatGPT is doing something a little more extensive, right? Writing a whole text response. There's one or two more kind of important things that ChatGPT does. So one is that it uses what's called attention, and that's basically just a way of allowing the algorithm to pay more attention to the parts of the text that are more important. So, I don't know what it would be in this case, but maybe Aristotle is sort of very important. And so basically, this allows the algorithm to focus on what's really crucial for understanding your query. So now, how did ChatGPT actually train these networks? So basically, they've sort of used a whole bunch of input data, which I'll explain in a second. But the whole process of training these 2 neural networks, it took them about 1.5 years. So, I think part of that was certainly kind of, getting the personnel to sort of write input and output questions. But part of it, I think, is actually, I could be wrong about this, but actually the physical delay in sort of training these networks actually takes time. And so I want to keep using this image of forming basically a map of different connections or patterns typically found in the training data. And this is a large amount of data. So this says 570 gigabytes. You might think 570 gigabytes is actually not that much data, but keep in mind that this is mostly not like images or videos. So we're talking about like text-based data. So actually, it ends up being quite a lot of data. ChatGPT is not the first GPT model put out by this group OpenAI. There's ChatGPT 1, 2, and 3. Basically, ChatGPT is sort of, as I understand it, based on ChatGPT 3 with some additional features. So in ChatGPT 2, you can see sort of the basic information that they used for training. But in ChatGPT 3, there's a lot more training. So 570 gigabytes, so more than 10 times more training data. That data has more diversity, so not just text, but also books, articles. So this is one thing, sometimes people say basically that, okay, ChatGPT just sort of downloads the whole internet. It's sort of like Google, it just searches the whole internet. It seems that that's not, obviously that's not how it works in an algorithmic sense, but also even the input data seems to be different. So you also have sort of books, articles. I'm not sure exactly what they've used there, but there's more diversity. And then the main thing is that they've changed the number of parameters. It's about 100 times, is that 100 times more. So what are the parameters? The parameters are exactly the number of connections between these neurons. So that you can say the number of connections or the number of weights, basically the number of different links in these mental maps. And so what they saw with ChatGPT 3 is that if they increased the number of connections by a huge amount, about 100 times, they could get much better results. And so this is sort of the differences from past models. You can see there's a little bit of a build error on this slide. So the other thing that was very useful for ChatGPT was the incorporation of data generated by humans. So OpenAI contracted a few dozen workers to basically write examples of questions and ideal outputs for ChatGPT. So they sort of generated a whole bunch of examples, and I think maybe put that together with data from other user inputs, maybe from past publications of GPT. I'm not really sure, but basically they ended up with 13,000 examples, and then there was another element of the training in which basically ChatGPT took an input and generated like 4 to 9 different outputs, and they asked humans to rank those outputs from best to worst. And then basically they gave the model, the algorithm, a reward for those outputs which were best. So this is an aspect of neural network training, right? Which is that you can say that it's rewards based, which is sort of saying, we're going to give the algorithm a reward for its best outputs, and it's going to adjust the weights so that it produces those outputs more often. So this is basically the first third of the talk. The next 2/3 are going to be shorter. But this is basically how it works. Now I want to think about a question which I think is absolutely fascinating, which is the relationship between how artificial intelligence, ChatGPT in particular, works and how the human brain or mind works. Certainly, we can't exhaust this topic. I think I'll probably want to study this over the next few years here in my philosophy program. But I did just take some time over the last couple of weeks to think a little bit about my first impressions of this relationship between ChatGPT and the mind. Maybe you have other ones. So the first impression is that actually there's a lot of things that are similar. So the name and the concept of neural networks comes from inspiration of the brain, how the brain works. So the brain is composed of neurons, right? And these neurons basically have two different sort of ends, right? So you have the axon, the terminals and the dendrites, and connected by this axon, which I recently learned can be quite large. So these axons, connect different areas of the brain. So you're talking about, centimeters or even sort of larger. And in fact, in some of these motor neurons that, go to different parts of the body, you could have, as far as I understand, axons sort of a meter or so in length. So these can be large. And the brain basically works by forming different connections between neurons. And so the axon terminals of one neuron fire and sort of release chemicals that transmit this electrochemical signal to the dendrites of the next neuron. And so maybe in the past there was sort of more of this idea that we can look at different areas of the brain and kind of identify different areas that perform different functions. And now I understand that it's more, people talk about more of connections between different areas. So we can sort of identify different circuits within the brain that perform different functions. And so the text that you can't really see there says that the connection strength changes with learning. So of course we're sort of learning throughout the whole life of a person. There are sort of particular moments in which you learn more or less. But basically, when we learn, the connections between neurons are modified. And this happens in sort of two ways. One is that actually you can have like physical neuron growth. So there's different sort of wiring of neurons together. And another is the sort of more simple, just changing the strength, that sort of chemical interaction at the interface between two neurons. So here you have basically an MRI-based sort of a constructed image on the left of connections between different nerve cells, and on the right you have a simplified sort of network model of one of these circuits within the brain that performs some certain function. And so in some ways, the brain is very similar in some ways to a multi-layer neural network. There are sort of these connections and training weights, and these things are modified as we learn. They're often reward-based. So, when you sort of successfully make a decision or successfully move a different part of the body or whatever, there's sort of this reward that trains these connections. We can sort of skip over this, but basically even the sort of function that determines whether a signal is passed on to the next neuron is similar. Now, the interesting thing is that I mentioned ChatGPT has 176 billion connections within their sort of mental map, as we were saying it. The human brain still has more. It has 1 trillion connections. But, they're orders of magnitude not that different, and it kind of makes you wonder, okay, well, maybe ChatGPT can't quite do all the things that a human person does, but what happens when, let's say, GPT-4 comes out and there's 2 trillion weights, or there's a number more than that of the human brain? So what's going to happen then? And I think that's a reasonable question. It certainly got me thinking, and so this kind of makes you wonder if basically ChatGPT has this sort of input-output system with 2 neural networks, and the brain has sort of a similar input-output system with human neural networks. Are we basically just the same as ChatGPT? And obviously here, I don't want to sort of create a definitive answer to this question, but a few things to think about. So one thing to think about is that we are not just the human person is not just the brain. So the human person is formed by the whole body. So in philosophy, there's sort of this idea of body soul composition. But just at a basic level, that is to say that there are certain types of reasoning or learning that occurs in the person that are dependent upon the rest of the body. Actually, this is probably all learning is dependent. I mean, just the input that you get through the senses, doesn't reach the brain unless it's come through the rest of the body. And I think also now there's sort of these models of, I forget if it's called sort of 4E learning or 4E cognition or something like that, which even emphasizes that the cognition of the human person is based not just on the body, but on the whole environment around the person. So, I mean, I just put a couple of examples. Thinking of these bottom 2 examples, say that on the bottom left there's an ice cream cone, and on the bottom right there's a couple, let's say, who's in love. Let's say a little bit more, let's say a little bit more important or transcendent than the ice cream cone. But I was thinking both of these examples are sort of human experiences that are not strictly intellectual. So, in Italy we have gelato. So I'm kind of a fan of pistachio gelato. So I can tell you what a pistachio gelato tastes like, but I don't think you can really capture that with just sort of an input text. So I don't think, a paragraph of text will not really give you the experience of what it is to eat gelato. I think to have that experience, you really need to come to Italy and try a pistachio gelato, and in some way that that gives new knowledge that passes by way of the corporal senses. And similarly, even things like emotion, passions, affection, things like that, anger, joy. So these have an intellectual component, but they also have this physical, very sort of component, which can't really be sort of captured just in the brain. It involves sort of the whole body. I mean, there's basically different corporal parts of this. So that's just to say that in some ways, learning is not just dependent on what's inside of your skull. On the top, I have a picture. This is supposed to be a child making a decision, and that's to say that the way that we learn is heavily dependent on our own decisions. So you can talk about, from a philosophical point of view, the will, or you can talk about free will. Obviously, there's different debates over sort of what that really means, but certainly we have the experience that our decisions direct how we learn, and we can choose to learn certain things and not learn other things. So that's sort of one way of sort of broadening the idea of how the person learns, which is not present in the same way as it is in, let's say, artificial intelligence. Now, this point is a little more subtle. So what I want to say here is that when you ask the question of how artificial intelligence works, it really depends on what you mean by intelligence, or as I've put on this slide, what you mean by knowledge. So one point of view we could say is kind of a realist point of view, which is sort of, I think, the main point of view present in sort of, let's say, people in science or technology, or certainly the main view that was present before, let's say, before modernism or before the Industrial Revolution, the Enlightenment, things like that, which is that knowledge is the discovery of reality. So I'll give a few examples. If you go sort of back to Greek philosophers, I think it was Heraclitus who was one of the first people to talk about logos, which is a certain order or a certain harmony present in nature, present in reality. So he kind of wanted to discover this logos or harmony. You have Aristotle, who, in addition to being a philosopher, was also a biologist, certainly not with the same methods of today, but with, I think, the same sort of interest in figuring out how reality works. And so he developed a list of, I think, 9 categories. So these categories were features of reality, especially of living reality as he saw it. So he talked about quantity, quality, time, place, action, passion, sort of different things that he observed in the physical specimens that he was studying. And basically, he used the different categories to describe reality. And this is sort of just to put it on the slide, but later you have this whole debate about what it means to exist. So if I talk about a tree, I can talk about quantity, quality, time, place, and sort of all the different aspects of the tree. But then some philosophers like Thomas Aquinas make a big point of saying, okay, but the most important thing is the existence of the tree. So a tree in The Matrix, for example, thinking of the film, is different than a tree in reality. And actually in The Matrix, you have this whole decision in the film of whether you should take, what is the blue or the red pill? I forgot the colors. Basically, whether you want to leave the Matrix or not. And if you think that reality doesn't make a difference, it's just better to stay in the Matrix, right? But you can see that basically some people say, no, this is not real. This is a simulation. And I need to go to the real world. So I need to go to what really exists. Anyway, I don't want to go too into this, but the idea is that for these philosophers, we observe reality and we discover reality. And so in that process, information goes sort of from reality to us, and reality becomes intelligible through what we observe in reality. There's a whole another point of view which is quite different, which is that basically everything we know in reality is just based on sort of a model that we have in our minds, that we actually can't know the tree. So this, you have different philosophers like David Hume, who basically, contrary to most philosophers before him, said that we can't really observe things like cause and effect in nature. There is not this order or logos, right? It's just habit or custom. It's just our own point of view which views this order in nature. So then you have Immanuel Kant, who kind of had these different categories which were pretty similar to the categories that Aristotle used in some way. I think he also talked about quantity, quality, time, place. But Kant said that it's not that we find these aspects of reality, it's that these aspects are in our head already. They're sort of, I think he would say, I'm not sure, I think he would say they're sort of innate ideas in our mind, which we then apply to reality, even if those things we can't really know whether they're in reality or not. This is just sort of to say this gets to a certain point in which basically you have some analytic philosophers who define our concepts of reality by basically functions. You can sort of represent everything almost by a mathematical function in the mind. And so in this point of view, the source of the intelligibility of nature is not nature, but it's rather us. Now, there may be some advantages to this system, but sort of one of the critiques or criticisms, there we go, I've sort of changed into Italian. One of the critiques is that this sort of locks you in a loop in which our view of reality is sort of contained within our own mind, and we're sort of skeptical about what we can know about what is really out there. So I think that this is a limitation of sort of this post-Kantian philosophy. And I think that if someone has the concept of knowledge as this mere sort of description of phenomena, then I think basically ChatGPT can do this pretty well, maybe just as well as the human person. And so, yeah, I think that ChatGPT does not know whether it's in the matrix or not in the matrix. It really doesn't care about that. And so if we're content to just sort of have this point of view as the internal description of impressions or phenomena, then we can consider that ChatGPT is intelligent. But if we want to have this view of abstracting, as it's called, from reality, the view that we actually discover these sort of universal ideas or qualities in reality, then that's something that ChatGPT can't do. And so this leads us into the last section, which is sort of the ethical implications of ChatGPT. Again, this is something that's just a few months old at this point, so obviously we can't exhaust the topic. This is just sort of my thoughts that I've been developing in the last few months. And so the first sort of thought here is this, that basically, like many other technologies, in my opinion, ChatGPT will be used well, it will be used ethically, in as much as it connects us with reality. So I think that's true, for instance, of the iPhone, right? So obviously there's tons of good uses of the iPhone. It can also help to connect people, but when used, let's say, poorly, in my opinion, it ends up separating people from people and just kind of become locked in the screen. Maybe that's true in some sense of other technologies. Sort of, Google Maps sort of tells you where to go, but then there's this sort of fact that you may actually forget how to get there. And so I think with ChatGPT, this will be sort of even more pronounced in the sense that, for instance, when I was preparing this talk, I did use ChatGPT to some extent. I sort of asked ChatGPT just a few minutes ago what David Hume thinks about cause and effect. So I think in that sense, I've learned more about reality with ChatGPT. Now, if I had used ChatGPT to write the entire script of this talk or to create the presentation, which I think it doesn't do now, but conceivably in a few months or maybe a year it could do, I think that would separate me from reality. I think that would not actually have helped me to learn about how the technology works and how sort of human intelligence works. So this is the first ethical issue that I thought of. When I'm talking about ethics, I'm not just talking about sort of what is legal or what should be prohibited. I'm talking about really what is helpful or what is useful for us. What are good uses of this technology. So I don't want to say that certain things sort of should never be done, but the question is, how can we use this technology in a good way? So one is connecting with reality. Another is development of the person. So I mentioned that when you have something like Google Maps and you sort of use that habitually to get from place A to place B, you might actually forget how to sort of be aware of your surroundings and to navigate without the aid of that technology. I think maybe in the case of Google Maps, that's not really a big deal. It doesn't really matter. But in the case of ChatGPT, it's pretty important because if we sort of rely exclusively on this type of technology, there will be ways in which we lose our ability to reason by sort of exporting it to this technology. Now, I think there's actually a good side of this, which is that, I was thinking recently about, let's say, students doing a university degree, or even more so doing like a master's or a doctorate. And sorry about that. I think ChatGPT helps you to say, in what way am I doing things that ChatGPT can't do? Because, sometimes you might spend a whole university education developing, sort of memorizing things or sort of learning how to write essays or whatever. But what's really important is sort of this out-of-the-box thinking, which can help to differentiate us from just what sort of an algorithm can do. And maybe there's actually not a huge need to learn how to do what an algorithm can do. Maybe there is some need, but we'll sort of leave that as an open question. Anyway, so second issue, trying to use ChatGPT in such a way that it develops us, it develops the person. I mentioned that there's this issue in neural networks in comparison with traditional networks, which is that, well, traditional networks can explain how they've made decisions. Neural networks often can't do that, or at least are struggling to do that. So there's this question of transparency that people are working on this to try to make the decisions more transparent, and that leads directly to the same question in terms of accountability. So let's say that instead of writing a text, I'm talking about driving a car. So if I have a neural network driving a car that decides to make a decision which causes an accident, I want to be able to hold the car or the neural network or the company or the programmer accountable. And that gets a little bit difficult if I don't know how the decision was made. So this is one sort of open task, I think, which is to work on this accountability of neural networks. The next ethical issue is intellectual property and reliability. So this is something that different companies are sort of claiming, companies that are maybe a little bit afraid of how ChatGPT is kind of taking over different domains of research or whatever. And so they raise this legitimate constraint, which is that basically in the end of the game, ChatGPT is drawing all this data from different books, text, articles. And this raises the question of when ChatGPT gives you a response. So let's say I ask it, what does David Hume think of cause and effect? It gives me that response. And then I may take that and sort of paste that, hopefully not, but maybe just paste that in an essay that I'm writing. But the question is where, or let's say a product that I'm creating. And the question is, who owns that intellectual property, or who am I supposed to cite when I sort of copy and paste that information from ChatGPT? So yeah, I think I've advanced to the next point here. But and this is also relevant for reliability, which is to say that you may have noticed this in ChatGPT, which is that it's capable of creating these amazing responses, but oftentimes it makes mistakes or even sort of invents things. So one of my friends was working on his doctorate and did a couple searches relevant to a historical author on ChatGPT, and was impressed to see these sort of citations that he had never read before, and sort of went to these primary sources, to the physical books, and realized these citations were completely invented. And so this is not, in the end of the game, ChatGPT is a text generator. And so it tries to generate the text that best responds to what the user asks. But there's, sort of no absolute guarantee of the accuracy of this information. And now the second to last point is impartiality of information. So as I mentioned, a big part of the development of ChatGPT was the input from different humans, different people who wrote sort of ideal inputs and responses. Now, whenever you have this sort of thing happening, there's always the potential for biased data, right? So I think they sort of took different parts of the population that they considered to be a broad sort of sample, but still there's always going to be some particular point of view which is represented or overrepresented in the data. And so this is important when you ask ChatGPT about sort of big questions, sort of big questions that sort of we might face in decisions, or kind of understanding life and relationships and all this sort of thing. You can't really expect the response to be any better than just sort of the average of the response that you have online, or of books or articles. And so there's always going to be this sort of closed loop in which the information is ultimately coming from people, even though it's combined in these new impressive ways because of the sort of mental map that ChatGPT has generated. Still, there is this basis in human input. Finally, emphasis on human relations. So this point is a little bit like apocalyptic. There's so many movies about sort of the robot takeover of the world. I'm not that pessimist, but this has made me think quite a bit, because I've heard, I don't know if this is true, but that there are some doctors who, if they have a patient who's like in extreme suffering, and the patient has no sort of friends or relatives to visit him, that there is like an engineering lab which has developed this robot that will talk to the patient and sort of offer conversation to the patient. and advice and consolation. And okay, so maybe this is well intentioned, but for me, that's just not the same as talking to a human person. And so I think that there could be the temptation, seeing how good ChatGPT is at imitating human responses, of sort of replacing the human dimension. So that's it. I hope you've enjoyed the presentation. Obviously, this is just sort of meant to open the discussion about this new amazing tool, and also try to think kind of both technically and philosophically or ethically, because this, in my opinion, is something that really touches the core of our sort of experience of what it is to be human, to be intelligent. So thank you very much, and I hope you enjoy the presentation.